Hello everyone, welcome back to Math with Allison. Today we're working in our parametric and polar curve series, so we're going to be talking about parametric circles. So let's go ahead and dive in. We are just going to begin with a circle. On a circle we have a point x, y. Now how are we going to parameterize this? Because we know in general the formula for a circle is x squared plus y squared is equal to r squared. But what if I want to know the point at a specific time? I want to know the x position at a certain time, and I want to know the y position at a certain time. That's where we need to add in an extra parameter, which is our variable t, our time. So let's go ahead and try to parameterize this. Here we have the radius, right? And this little angle right here is going to represent the time. So at a specific angle, that's going to represent what time that we're at. So we also know the parts of this triangle, right? This is going to be our height, which is the y. And this right here is going to be the distance x, right? We go over x and we go up y. So we know how to find x and y in terms of t. Let's go ahead and begin with finding x. Now I know in relation to the angle, x is my adjacent leg, and I know that the radius is my hypotenuse. So using SOHCAHTOA, right, we know that x divided by r is equal to cosine of t. Now, if I multiply both sides by r, I get x is equal to r times cosine of t, right? Now I was able to find the x position in terms of our parameter t. Now I'm going to do the same thing for my y. I know y is going to be the opposite leg, so I'm going to have opposite over hypotenuse, which is sine. So y divided by the radius is equal to sine of t. So here, if I multiply the radius over, I get y is equal to r times sine of t. So that's how we get the equation, right? We get that x is equal to r cosine of t, and we get y is equal to r sine of t. Now let's go ahead and use this. We want to graph and analyze x of t is 4 cosine of 2 pi t. Y of t is equal to 4 sine 2 pi t. For this one, the t is going to be between 0 and 1. So we know that this is going to represent a circle, right? We have the cosine, we have the sine. Now let's go ahead and try to plug in some values in order to graph this out. So first we're going to plug in t is equal to 0. 4 cosine of 0 is always going to be 4 times 1, which is equal to 1. Sine of 0 is always 0, so we get 0. So our point is 4, 0. Now if we go down to our little graph right here, here is my first point. We're going to go ahead and call this 4, 0. That's going to be our starting position. Now time is going to start going on. First we have time is equal to 1/8. So we get 4 cosine of 2 pi over 8. That is equal to 4 cosine of pi over 4. Cosine of pi over 4 is root 2 over 2. If we multiply that by 4, we get 2 root 2. Sine of pi over 4 is the same thing, so we get 2 root 2. And so this is going to be our next point. So if we were to graph it out, that would be about right here. So now we can see the direction that we're moving. We're moving towards a counterclockwise orientation, right? Okay, so let's go and plug in 1/4. So instead of dividing by 8, instead we're going to be dividing by 4. So 2 pi divided by 4 is equal to pi over 2. Now, whenever cosines at any pi over 2, 3 pi over 2 is going to be equal to 0. So that's going to go to 0, and sine is going to be equal to 1, so we get 4. So we go up to the point 0, 4. So let's do that on our graph. We go up here to 0, 4. Now let's plug in 1/2, so we get 2 pi divided by 2. That just ends up being cosine of pi. So 4 cosine of pi, we get -4. Sine of pi is always going to be 0. So we go over to -4, 0, which on our graph is going to be over here. So again, we can keep filling in that orientation if you wanted to. Let's plug in 3/4 now, right? So this is going to be 2 pi times 3/4. This is equal to 4 cosine of, that's going to be 3 pi over 2. So cosine of 3 pi over 2 is going to be 0. Sine is going to be 1. So we move over to the point, sine is going to be -1. So we go down to -4. So we go 0, -4, which is going to be on our graph all the way down here, right? So we're moving in this direction. And now we can fill in that last point, right? Once we go back to 1, cosine of 2 pi is 1, so we get 4. Sine of 2 pi is 0, so we go back to our original starting point. So that is how we can parameterize a circle. So we just graphed it out. So the circle was parameterized, right? It was written in terms of t. What if I want to eliminate the parameter? Well, let's go ahead and use the fact that we know the equation of a circle is x squared plus y squared. One way that you could eliminate the parameter is you could plug in those values for x and y. So for x, we have 4 cosine of 2 pi t, right? All to the power of 2 because it's x squared, plus 4 sine of 2 pi t to the power of 2, right? So here we can square everything. We get 16 cosine squared of 2 pi t plus 16 sine squared of 2 pi t. Now notice here what happens when I factor out the 16. We are left with cosine squared of 2 pi t plus sine squared of 2 pi t. And remember, what's cosine squared plus sine squared? 1. So this is equal to 16 times 1, or 16, which we already knew that, right? It's equal to the radius squared, but that's one way you can do it. You can plug it in and you can solve it out. In general, what do these formulas look like, right? So for a normal circle, we have x squared plus y squared is equal to the radius squared. So x is going to be r times cosine of bt, and y is going to be r times sine of bt. What is b? We're going to go in and figure it out in a little bit later. Now, what happens though if we have a circle that is not centered at the center, right, at the origin? Then we have like an off-center circle, so we have x minus x naught squared, y minus y naught squared. The only way it affects the parameter is that we're going to be adding the x naught and adding the y naught to the x of t and to the y of t, right? So let's go and talk about like the orientation and stuff. So the circle is traversed, right? That means it's traveled one time as t varies over any length of interval, right? So the interval is going to be 2 pi divided by the absolute value of b. So if b is greater than 0, that means we're going to be moving in a positive orientation, so we're going in that counterclockwise direction. If b is negative, then we're going to be moving in the clockwise orientation, so that's going to be like the negative orientation. So in our example right here, our b was equal to 2 pi. So we went around the circle for t values between 0 and 1, right? Because we get 2 pi divided by b is equal to 2 pi divided by 2 pi, which is equal to 1. So our t values from 0 to 1 tell us that that is going to be the entire rotation, right? From start to end. Now let's go ahead and see an example. A turtle walks with a constant speed in the clockwise direction on a circular track of radius 4 feet centered at the origin. Starting at the point 30, the turtle completes 1 lap every 30 minutes. Find a parametric description of the path of the turtle at any time where t is greater than or equal to 0 in terms of minutes. So we know in general, a circle that's going to be centered at the origin has this general formula, right? We have r cosine of bt and we have r sine of bt. Now we also know that the amount of time it takes to complete an entire lap is going to be 2 pi divided by the absolute value of b. And we know it takes the turtle 30 minutes. So we get 2 pi is equal to 30 times the absolute value of b. And now I can divide both sides by 30, right? And that ends up simplifying to pi over 13 is equal to the absolute value of b. Now we need to think about the sine of b. He is moving actually in a clockwise direction. So that's going to be the negative orientation. So my b is going to be negative pi over 15. Great, so we found our b. We also already know the radius. The radius is equal to 3, right? And it tells us that directly in the problem. So we get 3 cosine of negative pi over 15t, and then we get 3 sine of negative pi over 15t. So let's go ahead and check if this parameterization is correct. So here we have it laid out. I have the circle that I want it to actually fill in, and we're just going to plug in t values. So of course, we're going to start at the beginning. T is going to be equal to 0. He should be at the point 30. So cosine of 0 is equal to 1, so we get 3. And sine of 0 is equal to 0. So here we start at the point 30, which is exactly where we wanted to start. Now we're going to move on to 15 over 2, or 7.5 minutes. If you're wondering how I got that value, it's because I wanted to check the orientation. So here we're starting at this point, and I want to go down this way because I know I'm moving in the clockwise direction. So that means this angle is going to be negative pi over 2. So I wanted to find a t value that would capture the cosine and sine of negative pi over 2. So what you could do is you could set the inside of the cosine, so negative pi over 15 times t, equal to negative pi over 2, and you can solve for t. You're going to solve for the t value that makes that true. So if I divide both sides by negative pi, those cancels out, and then I'm just going to multiply both sides by 15, so t is equal to 15 over 2. So that's how I found that t value, and that's how I get down to negative pi over 2. So cosine of negative pi over 2 is going to be equal to 0, right? Sine of negative pi over 2, that's when it goes in the negative direction, right? So it's going to be negative 3. So here we go down to the point 0, negative 3, which is exactly what we wanted, right? We wanted it to go in that negative orientation. Now we can plug in 15, so cosine of negative pi, negative 1, so we get negative 3. Sine of pi or negative pi is always going to be 0, so that goes to 0. So we go over negative 3, 0. Let's go ahead and check that on the graph. Beautiful, we're going in the orientation that we wanted to. Now we're going up to, that's going to be negative 3 pi over 2 if we're going that direction, right? So I plug in 45 over 2. You can do the same thing. You can solve for t, right? You set it equal to negative 3 pi over 2. You end up getting t is equal to 45 over 2. So cosine of 3 pi over 2 or negative 3 pi over 2 is always going to be equal to 0. Sine, though, that's going to be the upwards direction, so sine is going to be positive 1. So we get 0, 3. 0, 3. Let's go ahead and check that with the graph. We go this direction. This is happy. That's what we want to see. Now we want to plug in our last value, right? Now we're going down to negative 2 pi. We want to be back at the original starting position because this is going to be where he completes his lap. So here, when we plug in 30, we get negative 2 pi. Cosine of negative 2 pi is equal to 1, so we get 3. Sine is equal to 0, so we end up with a point 3, 0. So we go back to the original starting position. So that's all I have for us in this video today. If you enjoyed it, I have many more like it, so make sure to check out my playlists. They're linked down below. Otherwise, please give this video a thumbs up and comment other problems or topics you'd like to see done. Thanks for watching.